Okay, so this is a very hard question here. I definitely wouldn't want to see this come up in a test, but let's have a think about this. So there's no really strict formal method to do a question like this. So what I would start to do is just try and rule some numbers out. So what I think is we've got numbers, we're going to divide a number that's less than 100. So when we divide by 5, we know that the 5 is the biggest number, so that should give us the least options of the final digit of the number we'll end up with, which may sound a little bit confusing, but basically we know because every multiple of 5 ends in either a 5 or a 0, then that doesn't leave us with many possibilities, with what will leave us with a remainder of 4. Okay, so because it ends in either a 5 or a 0, we know that something divided by 5 will only give a remainder of 4. It's going to be something remainder 4 when the end digit of this number is either a 4 or a 9. So we know our number must be something 4 or something 9. Okay, so we've narrowed it down to numbers with these two final digits, but now we've got to have a think about which one of these is going to be. We'd like to be able to narrow it down to just one of these. Okay, so now we've got to think about dividing by 4 and getting a remainder of 3, and dividing by 3 and getting a remainder of 2. Okay, so if we're dividing by 4 to get a remainder of 3, we've got to think about multiples of 4 with an n number of 1. So multiple with an n number of 1 for this option, and multiples of 4 with an n number of 6 for this option. Okay, and then for multiples of 3, so we're dividing by 3, we're being left with a remainder of 2. We need to think about multiples of 3 with an n number of 2 or an n number of 7. Okay, so now let's think about the 4 times table. So in the 4 times table we've got 4, 8, 12, 16, 20. Okay, and then what we can think there is these, when we get to the 0, it means these n numbers are going to repeat from there. And this tells us there's actually no number in the 4 times table that will have an n number of 1, so we can actually cancel out this option straight away. Okay, but we do know that we will have some multiples of 4 with n number of 6. Okay, so we know it's definitely going to be something 9 now, but we don't know what the first digit is going to be. So we also need to have a think about the 3 times table. So let's go 3, 6, 9, 12, 15, 18, 21, 24, 27, and 28. Sorry, and 30. Okay, so we've got a lot more options for a 3 times table, but we know that it has to be an n number of 7. Okay, so now to find the next multiples of 4 with an n number of 6, we're just going to add on 20 each time. Because basically we can think that each n number will happen every 20. Okay, so because obviously we started at 0, and then to go from 0 to here we had to add 20. So that's going to be the same for all the times tables, and same for here. To get to for each n number to be repeated, we'll have to add 30. Okay, so if we do 16 plus 20, we'll have 36. That'll be the next number in the 4 times table with an n number of 6. Then we'll add another 20, 56, another 20. Okay, so we'll get to 96. Okay, then let's do it for the 3 times table. So our first one that ends in a 7 is 27. 30, 57, and 87. Okay. So we know it's going to be something 9, so we need something that ends in a 6 and ends in a 7. So we need timetables of 4 and 3 that ends in a 6 and ends in a 7 and are close to each other. So we've got, yes, we've got 56 and 57. Okay, so that means that our actual number we first identified here must be 59. Okay, so this will be the final answer. And then we could just check that really quick. So let's divide by 5. Goes in once, remainder of 4. Okay, so which works here. And then let's divide by 4. So it goes in once, remainder of 1. 4 times 4 is 16, remainder of 3. Okay, so that works here. Let's divide by 3. Goes in once, remainder 2. Goes in 9 times, remainder 2. Okay, so that works here. So our final answer is 100% 59.